Hey guys, welcome to chapter 4. In this chapter, we're going to start making chemical bonds. So what we've done so far is introduced ourselves to subatomic particles, protons, neutrons, electrons. Then we spent an entire chapter talking about electrons, configurations, and whatnot. Now we're going to see that those electrons are responsible for making chemical bonds. And then we're also going to talk about exactly what they do to create those bonds. So that's what chapter 4 is about. So bonding models, there's different theories that we can use to predict bonds. So some of the things that we'll be able to do by the end of this chapter is predict how atoms will form a bond together, what types of bonds, how that happens. We'll be able to predict and explain the shapes of compounds. So for example, sometimes you see compounds drawn like this, like as a straight line. Sometimes you see compounds drawn like this as more of a bent shape. So why do we draw one as a line and one as bent, even though both of them have 3 atoms? We'll predict that by the end of this chapter. And then lastly, these chemical bonds, the way they form, the shape of the compounds, will help us to explain some physical and chemical properties that we observe. So for example, water, when it freezes or it snows, it always forms a 6-sided snowflake. Ever thought about why? Water, when it freezes, gets less dense, which is very odd for something a solid to get less dense. So some of those like chemical and physical properties that we observe, like we can start to explain them once we know what a water molecule looks like. So just to kind of clarify some terminology here, a compound versus like a mixture. So a compound is going to be a pure substance composed of 2 or more elements that are chemically bonded together. So if I were to talk about a mixture, for example, maybe I'll create a mixture over here. A mixture would have like red dots, and then it might also have blue dots, but the red dots and the blue dots are not interacting with one another. They're just existing in the same space. That's as opposed to these guys over here, where we also have red dots and blue dots. But in this case, the red dot and the blue dot are chemically bonded together. They're touching, they're interacting. There's some sort of magical chemistry happening there. So that's the difference. That's a compound. And then if I look inside of this bubble, it's not actually 2 different substances. It's actually all the same. So if we call these blue reds, all of these are blue reds. There's nothing else. Everything is a blue red in there. Okay. So chemical bonds, compounds are composed of atoms that are held together by chemical bonds. So this entire chapter is going to be exploring, getting to know different types of chemical bonds. There's 3 types of chemical bonds that we talk about. Ionic, covalent, and metallic. We will spend the majority of our time, if not all of our time, on ionic or covalent. I do want to let you know that metallic does also exist. And here's just kind of some examples of those. We'll spend a lot of time with each of these, so it's not something you need to write down all this information right now. Just trying to give you a preview as to what's to come. So if compounds are composed of atoms held together by chemical bonds, well, what exactly is a chemical bond? A chemical bond is going to be the sharing or transfer of electrons to obtain a stable electron configuration. Okay. So here, when I say electron, it is implied that I'm talking about valence electrons. So remember, valence electrons were the only bonds that were available to bond. All of the other ones are kind of hidden from other atoms. We also know that valence electrons are the electrons in the outermost energy level. So they're furthest away from the nucleus, they're on the outermost energy level. So when other atoms approach, those are the ones they see. To obtain a stable electron configuration, so remember our most stable configurations are the noble gases. So the guys in 18 or 8A, they have particularly stable electron configurations. So all of the bonding is going to be to try to get their electronic configuration to match a noble gas's. That's the purpose of the exercise. And then lastly, we see the sharing or transfers. That's an either or. They can do either or. But that's exactly how we classify our bonds. Okay, so we see sharing or transfer. And then on the board, we see ionic or covalent. So an ionic bond is that first one, the sharing, or excuse me, is the second one. It's the transfer of electrons. So during an ionic bond, literally somebody gives away an electron, literally somebody takes on an extra electron, and there's this exchange or this transfer. For covalent bonds, that's going to be the sharing of electrons. So the electrons that I've highlighted with the ovals here, those are the electrons that hydrogen and oxygen are both sharing. They both have a claim to them. So covalent bonds would be the sharing of electrons. Metallic was also out there. I will tell you that metallic is a little bit different than both of these. Metallic is a pooling of electrons. You kind of pool it all together. All right, so we have ionic, we have covalent, one transfers, one shares. So how do we know what the atoms are going to do? How do we know if they're going to transfer? How do we know if they're going to share? So here's our last definition in this video. So ionic compounds are going to be a metal bound to a non-metal. So remember in our periodic table, I told you guys learn where metals and non-metals are, because that's going to help us to be able to correctly identify things in the next chapter. Well, here it is. So remember the metals, if you look at a periodic table, they're the vast majority of the periodic table over on the left-hand side. Non-metals are that teeny tiny little section in the top right of the periodic table where things like fluorine, carbon, nitrogen live. So when somebody from the left side of the periodic table bonds with somebody from the top right on the periodic table, that's where we'll see a transfer of electrons. Covalent is going to be two non-metals. So even though it's a teeny tiny little section of the periodic table, it's got a very, very big chemistry. There's a lot to talk about with covalent bonding. So when a non-metal binds to another non-metal, they will do so by sharing the electrons in a covalent bond. So that's it for our introduction. In the next series of videos, we're going to start to explore ionic compounds. And then when we're finished with our exploration of ionic compounds, we'll then start a series on covalent compounds. I hope you guys found this helpful.